So this is the video that we're just introducing series. We're not getting too deep into it today. That's what the rest of the unit is for. So, the definition of a series, do you guys remember what they are? How they're related to a sequence? It's a sequence where instead of having commas, you have plus signs. You're adding them together. So you're taking the terms of a sequence and you're just adding them up. Yeah. So it's a series is the sum of a sequence. The sum could be from an infinite sequence. So you have terms that go on forever. It's not like you're adding up 5 terms, but you're literally adding up the terms as long as the pattern goes, like forever. Or it can be finite, meaning you have a specific number of terms that you're trying to add up. So the notation we use is sigma because we're too lazy to write the whole thing out. So if I say from n equals 1 to infinity, then I'm saying start with the first term and add the terms up literally forever. So I would say add up the terms for the sequence a sub n, whatever that pattern happened to be. So what this notation means is you're taking the first term plus the second term plus the third term plus and dot 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 because it goes on forever. So technically this part right here, this is the series. This is what we write so we don't have to write forever. So they both represent the same thing. All right, so what we want to start looking at now is converging series and diverging series. Do you guys remember what you learned in pre-calc about this? Because you learned a little bit. Yeah. But you guys you probably weren't using the word converge and diverge. You were using if there's a sum or if there's no sum.
I remember something about less than you wanted.
Yes. So in the past, we only looked at the sum if you had a geometric series. Well, we looked at sums for all of them actually, but for an infinite series, we only looked at geometric when the r value was less than 1. That was the only time that we could say it converged to a specific value. The rest of the time, it only worked if you had a finite sequence, if you had like a specific amount of numbers. That was the only time you could add them up. So here we're going to say that a series converges. So right now I'm not talking about a finite series, I'm talking about the whole series in general. The whole series converges if it goes to a specific value. So I'm going to say the sum of the series goes to a specific value. Not got, goes to. So then we would say that the series diverges if the sum of the series does not go to a specific value. Okay, so next, in class there's been a couple times where I've tried to write down like the formal math definitions of things so you guys could see what they look like, so that you're not, when you get to college math, if you choose to do that, you're not confused when you see something that looks kind of messy. So what we're going to write next is the definition of a divergent or a convergent series, just so you guys can see how they would have worded it in like a math textbook. So we're going to write this definitions. So for the infinite series, so the sum from 1 to infinity of the sequence a sub n, the nth partial sum is, what do you guys think I mean by partial sum?
Stopping at a certain number.
Yeah, I'm not going to infinity. It's going to tell me a specific number of terms it wants me to add. So it might want me to add like the first 20 terms. It might want me to add from term 5 to term 80, something like that. So the nth partial sum is going to be S sub n. So you're telling the person which sums you're adding, or which terms you're adding. S sub n equals the first term plus the second term plus the third term, all the way up to the nth term.
I have a question.
Yeah.
Would they tell you to start on a certain number other than 1?
Assume that it's 1 unless they say otherwise. Yeah. So it used to be in your math class they might have said, find the sum of the first 20 terms. They might say that. Now they might say, find the nth partial sum, and then they'll say like S sub 20 or something. So now you have to just understand a slightly different like notation for what they're asking for. But this is essentially the same thing as what you learned before. We're just, now that we're in calculus, we're going to branch out from doing only arithmetic or only geometric sequences and series. We're going to look at things that don't have patterns that you can like categorize that way, but you can still work with. All right. The next part of the definition says, if the sequence of partial sums So when I say the sequence of partial sums, I'm talking about S sub n, so that's the sum for a certain amount of terms, converges to S, then the series from 1 to infinity of a sub n converges. So what they mean by this is if you found S sub 1, so it's just the sum of the first term, and that's it, and you looked at S sub 2, the sum of the first and the second term, and you looked at S sub 3, the sum of the first term, second term, and third term, if you like listed out all these different sums and you can see that the sums are getting closer and closer and closer to a specific value, then you could say, oh, that series overall is converging. Does that make sense? So you're not just saying, oh, the sum of the first 20 terms is this, therefore there's a sum for the series. No, you're looking at the sum of the first term, the sum of the first and the second term, the sum of the first, second, and third term. You're looking at all the different sums and comparing all the different sums to see if it converges. You guys see the difference there? You see, so we're looking at if the sums converge overall. So we're not looking to see if the terms converge. We're looking to see if the sums converge to a specific number. Okay? All right. The limit S is called the sum of the series. So if you're looking at all of those different sums and they do not appear to be closer and closer to the same value, then you're going to say that the series diverges. So if the sums diverge, then the series diverges. All right, and we have two examples. The instructions say find the sequence of partial sums and determine whether the series converges or diverges. So for the first example, the sequence that we're going to find the sum of is just n. So that means that your first term is 1, your second term is 2, your third term is 3, your fourth term is 4, etc. Now when it says find the sequence of partial sums, what they mean by that is find the sum of just one term, find the sum of the first and second term, find the sum of the first, second, and third term, find the sum of the first, second, third, and fourth term. That's what they mean, because when we find all the sums in a list, we're going to say that's a sequence, and then each of these is a partial sum. So sequence of partial sums. Yeah.
Is there a specific, like, will we always just go to 4, or should we be able
You'll-
to see the pattern by then?
You'll see the pattern by then. So you go long enough to be able to see if it feels like it's converging or not. So the first term is just 1. The sum of the first and the second term would be 1 plus 2, which is 3. The sum of the first 3 terms would be 1 plus 2 plus 3, which is 6. The sum of the first 4 terms would be 1 plus 2 plus 3 plus 4, which is 10. So if you think about how these numbers are working, if you look at all your sums over time, do you think that your sums are getting closer and closer to one specific value? No. What's going to happen eventually? What's your sum going to get to be? Infinity. It just goes up forever. So as long as you go, it goes up. Now, if I was looking at this, there is a pattern to, if you compare the sums, if you ignore everything else and you just say that your first term of the sequence of partial sums is 1, and the second term of the sequence is 3, and the third term is 6, and the fourth term is 10. The pattern to this is that it's n times n plus 1 over 2. And if you look at that and are like, I never would have gotten that, don't worry, I would not have gotten that either. However, we don't necessarily even have to take this and evaluate it as a limit as L or as n goes to infinity, because we can already know, looking at the numbers 1, 3, 6, 10, we already know the limit of this is infinity. So even if you don't have a formula to plug it into, you can still tell that this is going to infinity. Does that make sense? All right. So, but if you check it, it does work. So the sum of one term would be 1 times 2 divided by 2, which really is 1. The second would be 2 times 3 divided by 2, which is 3. So the pattern works, yeah. So here I would just say overall the limit as n goes to infinity of s sub n, so whatever fifth term, or some of the first 5, some of the first 6, whatever, eventually you're going to go to infinity. And so we're going to say because of that this diverges. Okay. How are your brains feeling about as far as understanding the vocabulary of what we're talking about? That's okay. Yeah. Okay, let's look at the next one. So this one wants us to do the same thing, and we're going to say from 1 to infinity for the whole series. And our pattern is -1 to the n power. So again, we're going to find, we'll just find as many as we need to for us to kind of understand what's going on here. So what would your first term be? negative 1. So that sum there is just negative 1. What's the second term? Yeah, so this would be negative 1 plus positive 1 if we're doing the sum of the first two terms. What does that give us? 0. What would the third term be? Negative 1. So for the first three terms, we would say negative 1 plus negative 1. And that would add up to negative 1. If we were to add up the first four terms, you would say negative 1 and positive 1 and negative 1 and positive 1.
0.
So that would add up to 0. So what's going to happen with our sums as we go forever? They alternate between negative 1 and 0. So are we converging to a specific value? No. Do you guys remember what we say if we do the limits? Oscillates, yeah. So one of the ways that a limit could not exist was if it oscillates between two different numbers. And we haven't run into that a lot, but that happens on this one. It does oscillate between negative 1 and 0. So the S sub n is negative 1 or 0. Negative 1, 0, it kind of depends on which one you're on. And so we're going to say the limit as n goes to infinity of the sum of the series is going to be does not exist because it oscillates. And so that's going to give us the conclusion that it diverges.